Alright, today we are continuing our solving unit, and you are solving one-step equations with multiple operations. Today we're focusing on multiplying and dividing. That's what we're doing today. We're going to solve one-steppers through multiplying and dividing. So again, we want to apply inverse operations, so I always ask myself, what am I doing to the variable? What's the inverse of it? So this is 3 times x is 33. What's the inverse of times? Divide. So I'm going to divide both sides by 3. The 3 cancels and you get x equals 11. Now here's what I never want to see my 8th graders do. Don't ever show this. That is very young form of symbolizing division. You have to show symbolizing division as a quotient or ratio or division law. Okay? So, there you go. Alright, next one. Negative 2 times x is 20. What's the inverse of times?
Multiplication.
No, what's the inverse of times? Divide. Divide by negative 2. The negatives 2 cancel out, and I'm left with x equals 20 divided by 2 is 10, and they're different signs, so it's negative 10. Again, I always read my number aloud, or my problem aloud. X over 5, or x divided by 5 is negative 9. What's the inverse of divide?
Multiplication.
Multiply. So I'm going to times, see how I used it as a dot, not an x? So I put dot 5 to both sides. That cancels out my 5, and you get x equals negative 45. This is actually more of a 2-step, this last one here, before we get to fractions. So I have negative x divided by 4 equals 12. I need to start isolating my x. So what is the inverse of dividing by 4?
Multiply.
Multiply by 4, and you get 48 equals, the 4's cancel, but I'm still left with negative x. I have to get rid of that negative, because x isn't by itself right now, the negative is with it. You need x all alone. So that's really negative 1. So you could divide through by negative 1, and x equals negative 48. Alright, so that's definitely lower rigor level. But then we bump it up to apply it with fractions. Alright, fraction equations. If it's a whole number, put a 1 on the bottom. It's much easier when you're dealing with fractions to just make it all fractions. And then what you do is multiply both sides by the reciprocal. Our goal is to cancel, to get rid of. And so when I think about getting rid of, I think about they should be on diagonal so you can cross them out. Okay, so the first one, I have 2/3 x equals 6. I'm going to go ahead and put a 1 on the denominator. So 2/3 x equals 6 over 1. Now I need to get rid of the 2/3, so I'm going to multiply through by the reciprocal. That's because now my 3's can cancel and my 2's can cancel. But the multiplication property of equality says what you do to one side, you must do to the other side. To keep that balance. 2's cancel, 3's cancel. I'm left just with x. Now this is where you have to remember when you multiply fractions, it's top times top over bottom times bottom. I am going to cross simplify. So now it's going to be 3 times 3 over 1. 9. X is equal to 9. Top times top over bottom times bottom. Maybe you need to remind yourself that if you forget. Because you're going to be doing that a lot today. Bottom times bottom. So when you multiply fractions, you always multiply the tops, multiply the bottoms. do not get common denominators. You only get common denominators with adding and subtracting. 1/7 x equals 5/8. Goal, get x alone. So I need to move 1/7. So I need to be able to cancel them out. Do you see how I did that? I want them on the diagonal so they cross out. Do it to both sides to maintain that equality. Okay, that cancels this whole side out. The 7's cancel out, the 1's cancel out. I'm left with x. Now, I check to see if I can cross simplify. Nope. Nope. So it's top times top over bottom times bottom, 35/8. Leave it like that as 8th graders. Okay? A trick for the first example. Let me do the first example again. And some of you might like this strategy. It only works when you have a whole number though. This one, the second one, you always have to times through by the reciprocal. You have to. So this is like saying 2/3 x equals 6. Or 2 divided by 3 times it by x is 6. I can get rid of that 3. If you hate fractions, I can get rid of that 3 right away. What's the opposite of divide by 3? Okay, now watch. If I times through by 3, equality of multiplication says I need to do it to both sides. Look what it will do. This is amazing. And you're left with 2x equals 18, and then you're comfortable. Now divide by 2, x is 9. Let me show you another example. 3/4 x equals 5. You can get rid of that denominator by timesing both sides by 4, and you get 3x is 20. Divide by 3, x is 20/3. I like doing that. That's what I personally do. That's my strategy. I always get rid of my denominator first. Only if it's a whole number though. If you have 2 fractions, you have to do reciprocal. Okay?